So suppose we're trying to find the equation for this plane. We know that the origin is down here somewhere at the point 0, 0, 0. We have a plane up here, and suppose that we know a point on the plane, this x naught, y naught, z naught point, and we know a normal vector. We know a vector that is perpendicular or orthogonal to the plane, right? At a right angle to the plane. So we're going to try to come up with an equation for this plane. So we're going to introduce a position vector here, a vector from the origin out to any old point on the plane, any old point x, y, z. We're going to call this vector r. Now we're going to introduce a second vector running from the origin, again a position vector, out to the point x naught, y naught, z naught, and we'll call this vector r naught. Now, between these two vectors, we can find the difference vector. So we can find the vector r minus r naught, right? And that vector is going to run from r naught to r. Okay, so that is the vector r minus r naught. This vector lies in the plane, or at least parallel to the plane, and because it connects 2 points in the plane. Now, because the normal vector is orthogonal to the plane, it is also going to be perpendicular to this vector r minus r naught, which means, if we remember from our dot product, that the dot product of r minus r naught and n is going to have to be 0, because those vectors are going to be orthogonal. Distributing this, we get r dot n. So distributing this and then moving it to the other side, r naught dot n. Now, if we notate our vector n here with components, let's say a, b, c, then this would be x, y, z, vector x, y, z, dotted with the vector a, b, c, equaling x naught, y naught, z naught, dotting with a, b, c. And here we're going to get a times x plus b times y plus c times z. And over here, we're going to get a times x naught plus b times y naught plus c times z naught, which is all going to be a constant, and so we could simplify that all and just say it's equal to a constant of some sort. And this is the general scalar equation for a plane.